Okay, so continuing on, the next couple of problems are all going to be SOHCAHTOA problems. So like I said, we're going to get some examples for SOHCAHTOA in here. Okay, so for this one, I'll grab my formula chart. All right, so I recommend when doing SOHCAHTOA, start by labeling your sides. The hypotenuse doesn't change. It will always be across from the 90 degree. Your opposite and adjacent change depending on where this angle is. So if this angle is in this corner, across from 40, that is your opposite side. Next to it, this is your adjacent side. If the angle were on this side, then this would be opposite and that would be adjacent. Okay. All right. So I'm gonna do this one time, okay, and I'm not gonna do it for the others, but I want to show you the three proportions that you could write with this triangle. So we've got a sine proportion, which is opposite over hypotenuse. So that would be sine of 40 is equal to x, the opposite, over 18.4, the hypotenuse. We could write a cosine, which is adjacent over hypotenuse. So cosine of 40 equals, we don't have the adjacent, so that would be, I don't know, over the hypotenuse, which is 18.4. Or we could write a tangent equation. The tangent of 40 would be opposite over the adjacent, which we don't know the adjacent, okay? So out of these three proportions, only one of them is something that you can actually solve because the other two, we don't know what the adjacent side is, so we can't use it. So that means we have to use sine. It's the only one that we have information that we can actually work with. So sine of 40 is equal to 8 over 8, sorry, x over 18.4. We need to get x by itself. If x is being divided by 18.4, we get rid of that division using multiplication. Okay? That's a times. Those will cancel on this side. You're left with x is equal to 18.4 times the sine of 40. Sorry. Times sine 40. Make sure you are in degree mode. Okay? And that would mean that that length is 11.8. Okay. Okay, sorry for the interruptions. It's the middle of the school day and people are coming in and out. Okay, so that would be your answer, is 11.8. Okay, this one I'm going to go a little bit faster because we did the detail on the other one. So once again, we've got an angle down here. This is our opposite side. This is our hypotenuse side. This is another sine problem since we're using opposite and hypotenuse. So sine of 50 is equal to 9 over x. This time, x is in the denominator. So it's a little bit more complicated to solve for x in this kind of problem. First, you have to get it out of the denominator. So you would multiply by x to do that. Okay. So you would have x times the sine of 50 equals 9. And then, in order to get rid of this, you would need to divide by the sine of 50. Because now these are connected with multiplication, you can separate them with division. So those cancel, and you're left with x is equal to 9 divided by the sine of 50. Okay? And that's what you can put into your calculator. So that's about 11.75. Okay. For 17 and 18, these are inverse SOHCAHTOA. So the difference between this and this is that these are solving for a side, these are solving for an angle. Now you start these problems off the same way. So labeling your sides based off of this angle, this is our opposite, and this is our adjacent, okay? you start them up. You start by setting them up the normal way. So you could say tangent of theta is equal to your opposite over adjacent, so 12 over 10. Now the idea here is that you have to get rid of the tangent to isolate theta, because you want to get to a point where you say theta equals something, right? So like how here, if we're multiplying, we use division to get rid of to cancel the multiplication. And if we're dividing, then we multiply to cancel the division. So the opposite operation of tangent is tangent inverse. I'll prove it to you here just for a second. So like if I did tangent inverse of tan of 40, you get 40. The tan inverse cancels the tan. So in the same way, if you do tan inverse of tan of theta, these cancel and you're left with theta. But because this is a balanced equation, whatever you do to this side, you also have to do to this side. So if I do tan inverse over here to cancel the tan, then I need to do tan inverse over here as well. And that's why we end up with this equation, tan inverse of 12 over 10. Okay? Now, you type this into your calculator, so you press second tangent to get your tan inverse button, 12 over 10. Make sure you're in degree mode, and you get it's about 50.2. And that is in degrees. Okay, so that's what this angle is right here, 50.2. Okay, I'm going to do this one a little bit faster since I went into detail on the other one. All right, so this time around, this is our adjacent side. This is our hypotenuse side. If I'm using adjacent and hypotenuse, that goes with cosine. So I'm going to do cosine inverse of the adjacent over the hypotenuse. I'm skipping several steps here because I know that this is what I'm going to get to. It's cosine inverse of the fraction. So cosine inverse 12 over 20 is about 53.1. And that's in degrees. And that's your answer. Okay. For these next couple of problems, these are SOHCAHTOA problems again, but they're word problems and you're going to have to draw the picture. Okay. So, a kite string is 100 meters long. Find the height of the kite if the string makes an angle of 38 degrees with the ground. Okay, here's the ground. Anytime you're talking about height, that is talking about a directly vertical, perpendicular to the ground height. So if it's asking for height, it's asking for this. Now, based off of the third side of a triangle, that means that this is going to have to be the kite string. This is the ground. That's the height. This is obviously going to be the kite string. Okay. Also, when you hold a kite, you don't hold a kite like a balloon. So in these kinds of word problems, you have to think about real-life situations. You don't hold a kite like this, where it goes straight up. Kites blow with the wind, right? So when you hold a kite, it's at a diagonal. Okay, that's why it's at a diagonal here. Okay. All right. So, using this, okay, here's our angle. So this is our opposite side. This is our hypotenuse side. Opposite and hypotenuse means to use sine of 38 is equal to opposite over hypotenuse. X is on top, which means when we solve for x, we're going to end up multiplying 100 times the sine of 38. And that gives us about 61.57. Okay. Okay. Next. A ladder is leaning against a building. It's leaning. So the ladder is like this. Okay, this is your ladder. It makes an angle of 65 degrees with the ground. So here's the ground. This angle is 65. Okay. The foot of the ladder, so here's the foot, is 6.5 feet from the building. So here's your building. Okay. That means that this is going to be 6.5 feet. How long is the ladder to the nearest tenth of a foot? Okay. If this is our ladder, then what that means is that this is asking for the hypotenuse. Okay. All right, now it's just SOHCAHTOA. So this is our adjacent side. We're solving for the hypotenuse. Cosine of 65 equals the adjacent, 6.5, over the hypotenuse, which is x. Okay. Since x is in the denominator this time, just like on the other problem, we're going to divide this time around. So 6.5 divided by the cosine of 65. Okay. So that gives us that x, it wants us to round to the tens place, so x would be about 15.4. All right, next. The angle of depression from the top of a 130-foot control tower to an airplane on the runway is 17 degrees. How far from the base of the control tower is the airplane to the nearest foot? Okay. Angles of depression are when you have a horizontal line of sight and you go down a certain amount of degrees from that horizontal line of sight. Okay. So in this case, that degree is 17. Okay. Now, the tower is over here. Okay, and it's 130 feet high. So again, a height is going to be perpendicular to the ground. Okay. So here's our triangle. Problem: the angle is outside of the triangle. However, okay, in these angle of depression or angle of elevation kind of problems, your horizontal line of sight is perpendicular with the ground, or the other horizontal line of sight. Okay? That makes these alternate interior, so these are congruent. So whether they give you depression or elevation, it's gonna be this angle in the corner of that triangle. Okay? All right. It asks, how far from the base of the control tower is the airplane? So it's asking about the length of the base. That's this down here. Okay. All right, so here's our picture. Okay. This is our 17-degree angle. This is 130 feet. This is x. Okay. This would also be 17. Okay. All right. So we're going to use this angle for SOHCAHTOA. This is our opposite side. This is our adjacent side. Opposite and adjacent go with tangent. So tangent of 17 is equal to the opposite, which is 130, over the adjacent, which is x. X is in the denominator this time. So because it's in the denominator, we're going to divide. Okay. Whenever you divide in these SOHCAHTOA kinds of problems, your sine, cos, or tan is always going to go on the bottom. Okay. So that's equal to about 425.2. Okay. Rectangle MARU has a width of 27 and a diagonal of 45. What is the perimeter? Okay. So here is our rectangle. MARU. It has a width of 27, and because it's a rectangle, opposite sides are congruent. Okay. It has a diagonal of 45. This is a diagonal in a rectangle. Okay, if it wants the perimeter, we need to figure out what are these sides. Okay, so then have a diagonal, we have a leg. because we're solving for one of our legs, we need to use Pythagorean theorem, and we're going to subtract this time. 45 squared minus 27 squared. All right, 45 squared minus 27 squared is equal to 36. Okay. All right, the last part is easy. So now that we have all of our missing pieces, we just need to add them up. 27 plus 27 plus 36 plus 36. Stop it. Okay, plus 36 plus 36 is 126. Okay, so that's centimeters squared since it's in, oh no, just centimeters because it's a perimeter. Sorry. Okay, all right. I'm going to stop the video for here. We're getting at 18 minutes. Also, the bell is about to ring. So I will continue the rest of this review in the next video.